All right, what's going on, my mathletes? That's right, Mr. Muscarella coming at you. And in this video, we're going to take a look at two problems from our trig unit that were on the review. So let's take a look first at this problem here where we have sine of arc cosine of negative 5 over 13. Now, when you see this, one of the first things that you're going to want to do is always go through and draw the triangle that is represented. Because arc cosine of negative 5 over 13, like that's not on the unit circle or anything. And remember, this inside function, we're trying to find an angle. And negative 5 over 13 is not something that's on the unit circle like 1/2 or square root of 2 over 2 or 0 or undefined or root 3 over 2. So that tells me that I have to go ahead and draw a triangle. So let's go ahead and do that. And this one, like a lot of the times you'll see this kind of problem, you're going to draw a triangle. And this is where you have to be careful here because the domain restriction for arc cosine, remember, you are limited to quadrants 1 and 2. Now with cosine being negative, so what you're kind of thinking is cosine of some angle is going to give you this negative relationship here, this negative ratio of negative 5 over 13. So that tells me I'm in quadrant number 2. Now cosine is the relationship of x over r, so I'll put a 5 there and a 13 there. And then when we look at the triangle, we can kind of tell which of those two numbers gets a negative, and that would be the 5 because of its location in the coordinate axis. So once we have that, now to figure out the sine of this triangle, again, because it's not on a unit circle, right? So the sine of this triangle is going to be the relationship between y and r. And I don't have this y value right here. I'm missing that side. Now, some of you might recognize that real quickly as a Pythagorean triple. And if you do, booyah. So if not, you can always use Pythagorean theorem to find that. And when we're finding the side of a missing right triangle, so y would be the square root of 13 squared. Ooh, that was gross. I don't know what one note was doing there. So 13 squared minus negative 5 squared. And when you do that, you'll get 169 minus 25 square rooted, which is 144. And when you square root that, oh, that just ends up being 12. So the y value is 12. So the sine of this triangle, okay, so you can either we'll write that as sine and then arc cosine of negative 5 over 13. That has a value of the trig ratio 12 over 13. So that's how you do this problem. All right, that's this kind of problem right here. Now problem number 7, a little bit different. So when you're doing, backing up to here, question number 6, I mean, you've got to make sure you draw that right triangle, find the missing side in there, and then set up your trig ratio appropriately. Because remember, trig ratios have to deal with, regular trig problems deal with the ratio of the two sides. Now we're looking over here at this one, we've got arc sine of the cosine of 5 pi over 4. Now, what's really cool, this inside function, 5 pi over 4, the cosine of that is on the unit circle, so that's very nice. So when I want to figure out that value, so your brain kind of thinks like the cosine of 5 pi over 4, like that little chunk, we know cosine is the x coordinate, and if we've got our unit circle memorized, 5 pi over 4, the cosine of that is negative root 2 over 2. And so that value right there, so now I'm going to kind of go back to the inside, so arc sine of negative root 2 over 2 is going to give me some value of the angle. And I don't know what that angle is, so I have to then kind of rewrite it like this, like sine of theta is going to be negative root 2 over 2. Now, remember, we're dealing with arc cosine here, and we've got a domain restriction of arc cosine. Remember, that's that first quadrant and fourth quadrant, but from negative pi over 2 to pi over 2. So with that in mind, I've got to think about, all right, sine, that's my y value. Where is that going to be negative in those two quadrants? We know we're going to be down here in quadrant number 4. All right, now, remember with this one, again, it's real tricky because most everybody's like, oh, okay, well, that's going to be 7 pi over 4, and you got to be careful. Don't make that mistake. So when you write this, you're going to write theta equals and then your value. And it's not going to be 7 pi's over 4, all right, because that, my friends, is incorrect because you would leave the domain restriction that we got and come back in there. So you can't do that. So what we did in Archdeep, man, I love you for doing this. Archdeep, class of 2024 at Broad Run High School. He's the one that gave me this idea, and I loved it. He's like, yeah, just take that top number, 7 pi over 4. You're going to take the 7, knock that off, and then make it negative. So your answer should be theta equals negative pi over 4, and that is the answer to this kind of question. Now notice too the difference in the way these are written. One of them has theta equals and then your answer, and the other one is going to be a ratio. So you're going to have sine of, an inverse trig function equals then a ratio. So those are two small but very important things to make sure that you pay attention to when you are solving these types of problems. All right, that's it for this video. Thank you guys for watching. Make it a great day, and I'll catch you later. Peace out.